All right, this lesson is going to be on orbital notation. An orbital notation is essentially a pictorial representation of where the electrons are in an atom. And so we need to have an additional rule. So we're going to fill in Hund's rule, which is that final rule on our electron configuration. And we're also going to be over here in the orbital notation box. All right, what is Hund's rule? Hund's rule says 1 electron in each orbital before doubling up. All right. So what I've done is I've rewrote our electron configurations for phosphorus, oxygen, and copper. And we're going to draw the orbital diagram for these. Now, we've already learned that each orbital can hold 2 electrons. So what we're going to do here is the S sublevel has 1 orbital. So we're going to just draw that orbital and label it, or that S sublevel with the orbital. The 2s has 1 orbital. The 2p, the p has 3 possible orbitals. So we're going to draw 3 orbitals, and we're going to label that the 2p. The s has 1, and the p again has 3 possible, so we're going to label it. The 1s has 2 electrons. Now we're going to draw a half arrow up and a half arrow down. Those half arrows represent the spin of an electron. Electrons are always moving. What direction are they moving? How are they moving? That is the half arrow. One electron is moving in one way, the other electron is moving in the opposite way. All right, so we have 1 half arrow up and 1 half arrow down. The second energy level has 2 where I said second energy level, the second sublevel, the 2s, has a half arrow up and a half arrow down for the 2 electrons. The 2p has 6 electrons. Now here's where we get into Hund's rule. So far, we've only been filling Aufbau's principle. We filled the 1s before the 2s. Now we're continuing with Aufbau's principle because we're filling the 2s before the 2p. But Hund's rule says only 1 electron in each orbital, and then if we need to, we will double up. The p actually has 6 electrons, so in this case, they will double up. Now let me give you a good example of this. All right, let's say you play a sport, and so you're on the bus traveling to an away game. If there are empty seats on the bus, you and your bestie will sit side by side in empty seats. You won't actually sit in a seat doubled up if there's empty seats available, right? Because you've got your bags and you've got all kinds of stuff. So you'll only double up with your bestie if there's not enough space on the bus for you each to have your own seat. All right, Aufbau's principle says we fill 2p before the 3s. The 3s has 2, so 1, 2. Aufbau's principle says we fill the 3s before the 3p, but the 3p has 3, so here's Hund's rule, 1, 2, 3. We do not double up if we don't have to. So in this case, when you're traveling to your away game, you don't have to double up with your bestie. Y'all all get your own seats on the bus as you travel. So let's look at oxygen. Oxygen has a 1s, a 2s, and a 2p. The p has 3 possible orbitals. There are 2 electrons in the 1s. There are 2 electrons in the 2s. There are 4 electrons in the 2p. 1, 2, 3. Hund's rule. We do not double up unless we have to. I need 4 electrons, so one seat's going to get doubled up. One student is going to sit with their best friend on the bus as they travel to the away game. Copper, 1s, 2s, 2p. The p has 3 possible. 3s, 3p. The p has 3 possible. 4s, and then the d. We saw in a previous video that the d has 10 total electrons, 5 possible orbitals. So 10 total possible electrons and 5 orbitals for those electrons to be found. So 1, 2, 3, 4, 5, and we're going to label that 3d. Now we're going to fill it in based upon our electron configuration. Now your goal is to ultimately get away from drawing electron configurations using these groups that I gave you and being able to use the periodic table, because you will be given a periodic table on your assessment. You will not be given this particular worksheet that we used as an introduction. Your goal is also to be able to draw the orbital notation without having to first draw the electron configuration. So here we go. We're going to start, though, with the electron configuration because this is new stuff, and new stuff requires practice. So 1s2, 2s2, 2p6, Hund's rule. I do not double up unless I have to. Notice these are all up arrows. There are 6, so we are going to double up. 3s2, 3p6, Hund's rule. I do not double up unless I have to. In this case, I have to because there are 6. 4s1, remember we had an electron shift. And if you don't remember that and you're not quite sure what's going on here, you need to go back and rewatch the video on electron configuration. There's 1 electron in the S, and there are 10 in the D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this D is completely filled, which is optimal. So there was enough energy, it was energetically favorable enough for 1 electron to shift over here to give us an optimally filled D.